All right, hey there, everybody. Obviously, we're trucking on through the semester as best we can, and today we're going to talk more about world climates. I'm actually switching up this week with next week. Next week, we'll talk more about the changing climate. Keep an eye out for those emails and also reach out to me if you're having any trouble with technology. If you're having connection issues, just please let me know. You can actually text me. My cell phone is 540-798-0958. You can call or text me and we will get things worked out the best we can. I did send you an email the other day about the final project. I want you to kind of think about some of those questions and maybe get a bigger topic. And once you decide what kind of topic that you want to use, then or what topic you really want to focus on, then you can send that idea my way and we'll kind of discuss it and see how to get you off to a good start with that. And of course, the final will be due towards the beginning of May. Don't have an exact date just because of everything that's been going on. Our dates are kind of thrown up in the air just a bit. Now, your next assignments, it will be due the end of the weekend. Everything is basically now due at the end of the weekend. If you have any issues there, just please let me know. I'm going to try to make this as easy of a transition towards the end of the semester as I possibly can. So to get things started, we're going to talk about world climates, and there's obviously many different climates across the world. There's certain categories that are broken down into subcategories, but we're going to kind of hit the basics, and we're going to focus on the various regions, the various larger climate regions across the globe. So the way we actually classify climate is based on the Köppen classification. It's a tool that is based primarily on mean monthly and annual temperatures and precipitation. So temperature and precipitation will allow you to classify your climates, and it's actually organized into five principal climate groups. We have A, B, C, D, and E, and each of those refers to a different climate region. Your A is going to be your humid tropical climates, and all months have mean temperatures greater than 18 degrees Celsius. We're just focusing on temperature here. You can actually have a dry tropical region as well, but we'll get to that in just a moment. Your dry regions refer to not temperature, but obviously the dryness overall. Evaporation often exceeds precipitation. Now, it can be dry all throughout the year, but you could also have a predominant dry season and a wet season, but still, for the course of the year, evaporation is going to exceed precipitation. For your C classification, you got your humid mid-latitude climate regions, and that typically means you have a milder winter, and this is based purely on temperature. Your mean temperature of the coldest month is above -3 degrees Celsius and lower than 18 degrees Celsius. And for your D classification, this is really getting us up into the northern latitudes. It's a humid mid-latitude climate, but with severe winters, and your coldest month is typically less than -3 degrees Celsius, and that's the average mean temperature for the coldest month. It's less than -3 degrees Celsius, and the warmest month is higher than 10 degrees Celsius, which is 50 degrees Fahrenheit. In the polar regions, it's summerless, and the mean temperature of the warmest month is lower than 10 degrees Celsius or 50 degrees Fahrenheit. As we look at the globe as a whole, if we break it down into just the three areas, you have your torrid zone, which is closer to the equator. That's typically going to be your very humid and hot region. Your temperate zone, a little bit more livable. That includes much of North America and much of southern parts of South America. And this is really for Argentina. Your frigid zones, the Antarctic Circle and the Arctic Circle. So that's if we would break down climate just three different levels. But of course, it's not quite that easy. Here are your various classifications in a giant chart. And I'll leave this up for a little bit. I just want you to kind of glance at it a bit before we really get into breaking down our climates a little bit more. With your A climate classification, that is your humid tropical climates. But again, you can have a dry tropical climate and also a wet tropical climate. Your wet tropical climate is typically going to be your very lush green areas, your rainforests. Now, in your B climates, that can refer to basically any desert area, but it can also refer to areas that have a very distinct wet and dry season. And we'll talk more about that in just a moment. Your C climates, that is going to be more temperate, your mid-latitude climates. Your D climates, referring to those harsher, colder periods during the winter time, and then your E climates referring to the polar regions of the globe. So let's get into a deeper discussion. So we remember our climate controls. We know latitude obviously is really going to be your biggest climate control. In the higher latitudes, you will have a lower sun angle. In the lower latitudes towards the equator, you'll have a higher sun angle, and that's going to have a huge impact on temperature. Land versus water, marine climates are going to be milder than continental climates, but for continental climates, you typically have more extremes. You have hotter summers and colder winters because obviously the water will have a huge influence on the temperature near the coast. Geographic positioning, prevailing winds, the windward sides of continents are more likely to have marine climates as compared to the leeward side where it's drier and more continental. So this is just a little recap of things we learned in the past. Mountains and highlands, they can be barriers, they can trigger orographic precipitation. Obviously, higher in elevation, typically you're going to be colder as well. And ocean currents can lead to fog, like we often see in San Francisco and along the California coast. And it can also lead to warmer temperatures, just depending on which direction the current is coming from. If it's coming from the equator, like the Gulf Stream does, along the southeastern coast of the U.S., that's going to allow for warmer temperatures and also a fair amount of humidity as well. And your pressure systems around the globe, you obviously have things like your polar low, you have your subtropical high, and those regions, they kind of line up with certain climate areas. Subtropical high, high pressure typically means drier weather. And obviously, where you have the equatorial low, you have more rising air, you have more precipitation, and you're near the equator. So that means the climate is going to be fairly wet and fairly warm. And so pressure regions kind of go hand in hand with your different climate regions as well. So there's a general overview. You can see, take the cursor here, look over North Africa. That's deserts. That's your B classification. Towards the equator, you have the A classification, and you can take that over there towards Indonesia as well, Northern Australia. But of course, towards Central Australia, you got a big desert there. Got the Gobi Desert out here. Anywhere you have a desert, you've got the B climates. But where you see this darker brown, this is a dry climate, but you also have the rainy season as well. You also have a rainier season. So you typically have a very, very dry stretch of time, but you also have an influx of rain during typical parts of the year, during certain parts of the year. You can see your C climates in here, a little bit more temperate overall, milder winters. This also encompasses much of the Mediterranean and also northwestern parts of Europe, and that's because of the influence of the Gulf Stream. Now, more continental areas away from the coast and in those northern latitudes getting into more of that D climates, indicating those harsher winters. And then your E climates, that's towards the pole, back there towards Siberia as well. So your A's, your tropical climates close to the equator. Your Bs, where your deserts are. Your Cs are going to be kind of in the mid latitudes, especially near the coast or under the influence of the Mediterranean or maybe the Gulf Stream, as that kind of modifies Great Britain, Ireland, parts of France as well. But in the northern latitudes, it's getting colder. You're going to your D climate, to your harsher winters, and then eventually to the poles, where, yeah, it's just cold basically year round. All right, so we've got the wet tropics, and that's where your mean temperature is 25 degrees or greater, and you average a lot of precipitation. So it's wet all year round. Here's a good example of a wet tropical climate. You can see Malaysia here, looking over to the right, Singapore specifically. This line up here indicating monthly temperature. You can see not much of a change, and you can see where generally over 25 degrees Celsius, you can see 86 degrees Fahrenheit here, and then look at the precipitation. Lots of it, most months, we're averaging at least 8 inches of precipitation. So this is the epitome of a wet tropical region, Malaysia as well as Peru. We look at Peru here, we can notice that there's a slight dip towards the middle of the year, towards June, July, and August. Keep in mind, this is in the southern hemisphere. So temperatures, yeah, would actually be typically getting a little bit cooler, but temperature range there, only 2 degrees Celsius. Same deal for Singapore, and you'll notice the amount of precipitation is just enormous in both of those locations. All right, so we go from the tropical wet to the tropical dry, and a tropical dry region is often referred to as a savanna. This is where the rainforest kind of gives way to the tropical grassland. And these regions have distinct wet and dry seasons. Kind of ring a bell? Think about the monsoon season. Now, the daily temperature range exceeds the annual temperature range. So, your typical daily range is going to be higher than the range of temperature that you see throughout the course of the year. It's still going to be fairly warm overall, but you get a little bit more of a daily range, at least in those temperatures. And in terms of precipitation, you have a wet summer and a dry winter. Again, really corresponding with that monsoon season. So the monsoon, obviously, alternating periods of a lot of rain versus a lot of dry air. And that obviously just depends on which direction the wind is blowing. And we obviously see that wind shift throughout the course of the year, just depending on where high pressure is and where low pressure is. Now, during the winter time, you got high pressure over land that is pushing the air from north to south. It's moving on down the Himalayas out there towards the Indian Ocean. It's a continental, very dry wind that's blowing. And so that's going to keep those areas incredibly dry. But when you get into the warmer months, you get more heating over land. You get that relative low pressure to develop. And now you've got more of a wind coming from the water to the land. And obviously, that's when you get into wet season. Here are your dry climates all across the globe. So you got your arid and your semi-arid areas. And if you look across the US, of course, we've got the desert southwest, the Mojave Desert, the Sonoran Desert, and the Great Basin. Across the globe, the Sahara Desert, the Arabian Deserts, the Gobi Desert in China, and also the Great Sandy Desert. And one thing we'll notice with these areas is they kind of match up with the subtropical high. Remember, I was saying how pressure areas kind of influence the climate? Well, there you go. Obviously, higher pressure is going to be in place because you have all this rising air, but the air aloft, the higher pressure aloft, is just going to suppress that air and prevent it from cooling and condensing. Now your steppes, those are your semi-arid regions. Those are the areas that typically have a dry season and a wet season. Sorry, just going back a few here. Oh, I'm sorry. I said your steppe is your semi-arid region. Now it can be. It's not quite a dry versus a wet season like a monsoon, but you certainly get more precipitation. I want to make sure that I emphasize that. That's the reason why I was going back a few slides there just to make sure I did explain that correct. The steppe is a semi-arid area, not quite as dry as the desert. You have a little bit of a rainy season, but not to the extent of monsoon season. And you can see into India right here. They're not in the semi classification. That's more going to be classified as the monsoon region or the dry tropical climates. But you can see typically your steppes, your semi-arid areas are on the outskirts of your desert areas. Notice that. Same deal into Australia as well. So what is meant by a dry climate? Well, the yearly precipitation is going to be less than evaporation. So evaporation is going to be greater than precipitation. And so basically you have a loss of moisture every year because of the fact that evaporation is greater than precipitation. So here we go. We're looking at some dry climates here. And this is an arid climate, Cairo, Egypt. You can see down here, this is where we're measuring rain, and we're just not measuring much. During the summertime, you can see that we're almost all the way down to 0. Notice in terms of temperature, you get a little bit of a range here. You do get a range of temperatures in the dry climates because dry air tends to heat up very quickly, but also cool down very quickly as well. So you do get that temperature range. Now, in a semi-arid climate like Monterrey, Mexico, again, you're noticing a little bit more precipitation, not a ton. You can see your highest month is roughly 5 inches of rain, and that is into September, but most months are about 2 or less. So that would be a more semi-arid climate. But again, this is still different from monsoon season, where in monsoon season, you often see huge hikes in rainfall totals or precipitation totals during the wet season and relatively dry conditions, almost completely dry conditions during the dry season to where your precipitation is almost less than an inch. So this right here is a perfect example of a semi-arid climate and our classification B. So basically what I said before, you've got your arid climates and your precipitation is lacking all year round. In your semi-arid, I'll just put that here, your semi-arid climate, precipitation is a little bit greater overall as compared to your more arid climates. And not only you have more, you have the dry air in place, that obviously leads to that temperature range throughout the day and even throughout the year, but you also have a lack of clouds, and that makes for a greater temperature range as well. You have sunnier skies during the day, so it heats up more, but at night, with the clear skies, all that heat that built up during the day just escapes into space, and so temperatures cool down fairly efficiently. And also, the dry nature of the air is able to heat up and cool down more effectively because the specific heat is less. It doesn't require as much heat to heat on up. This map shows how many clear days you have typically across the U.S., and it makes sense that you're going to have drier days across the desert Southwest. You can see 220 of the roughly 365 days we do have sunshine. And this is actually showing an area where it's greater than 220 days. You can see around Northwest Pennsylvania, typically less than 100. Makes sense. We get pretty gloomy days during the wintertime. All right, now let's focus on the West Coast subtropical deserts. And you can see the list of the deserts here. Sonoran and the Sahara. I'm not going to try to pronounce these other two because I may butcher them. The cold currents offshore have a dramatic influence on the climate. You'll notice where some of these big deserts are. If you look off the western coast, that's where you typically have a very cold currents. And obviously with cold air is denser, sinking, it's not transporting that buoyant air that you need to allow for condensation and ultimately precipitation. These areas have cooler mean annual temperatures and smaller daily ranges. And that is because of the influence of that colder current. So this is just another type of dry climate. You have your mid-latitude deserts and your steppes, and these are actually mainly caused by the rain shadows, the leeward side of mountains. And these areas typically have they can get pretty cold during the winter, but they have a huge annual range of temperature. So here we go. Let's look at a few of these sea climates. Again, these are referring to the milder winters. You can see with a humid subtropical classification, like in China, you notice that there's enough precipitation, especially during the summertime. And you'll also notice that fairly great range in temperature. So now we're going from the dry climates to the more temperate climates. Let's just call it that. I mean, you'll notice the distribution of precipitation, yeah, pretty significant here. That's the reason why it's considered humid subtropical. You're getting a lot of rain throughout the course of the year. Marine West Coast climates, smaller range, not quite as hot, especially during the summertime, but still enough rain. And you got that Mediterranean climates, common obviously around the Mediterranean Sea, but also Los Angeles. Not a ton of rain, more of it during the winter months. And you can see your temperature range here. So let's talk a little bit more about the more temperate mid-latitude climates. So the humid subtropical climates, that is typically going to be found on the eastern side of continents between roughly 25 degrees and 40 degrees latitude. Here we're talking about hot, humid summers with a fair amount of rain. The marine West Coast climate is typically going to be a climate, the western side of a continent in the higher latitudes. At least this is looking at the northern hemisphere. You have mild winters, cool summers with precipitation really throughout the year. So these, again, are going to be very coastal climates that are really getting the influence of that prevailing wind off the Pacific. But of course, that wind coming in off the Pacific is also going to prevent temperatures from getting too hot during the summer, but also prevent them from getting too cold during the winter time. Now your dry summer subtropical Mediterranean climates. This is also typically located on the western side of continents between roughly 30 degrees and 45 degrees. So a little bit more southern than your marine West Coast climates. And it kind of lines up with the Mediterranean countries in Europe. Typically, you're going to have warmer summers. Well, depending on what exact classification you are. And you typically don't see a ton of rain in a Mediterranean style climate. We go back here, look at Los Angeles. They're considered a Mediterranean climate, but not getting a ton of rain in any given month. It's typically 4 inches or less, and really not much during the summer. So precipitation averages between about 40 and 80 centimeters a year, considered subhumid. All right, so looking at our sea climates, that again is referring to fairly mild winters. That's really what I want you to remember here. Again, there are multiple other subcategories. For example, here we have a type of Mediterranean climate in which we have warmer summers compared to some that are cooler summers. You're going to have the cooler summers generally in the northern latitudes, the warmer summers, the southern latitudes. So let's just make sure that we completely understand these classifications here. I'm going to go in back to the beginning of our mid-latitude climate breakdown of these various locations. Again, this is more temperate region. You can see the humid subtropical. We're getting enough rain all year around. It's still a pretty good temperature range. The reason why this is not the same as our more tropical climates, or at least our wet tropical climates, is because of the range overall. Your warmest months, typically temperatures around 86 degrees. Your coldest month, you're looking at mid-60s. So that's a livable range, and this is in China, obviously a very populated country. Into Alaska, got more of that marine West Coast climates. Obviously, you can see it's way up there in the northern latitudes. You get a decent amount of precipitation. We know the polar low is the Alaskan low has a huge impact on this area, especially during the late summer and into the fall and early winter. That's when there's a ton of precipitation. You'll notice that temperatures typically cold, but because it's near the coast, it's modified a little bit. So temperatures around freezing, that's kind of the average temperature. But then during the summertime, it can be fairly nice. Talking about temperatures around 60 degrees. This area of Alaska is notorious for lots and lots of mosquitoes because it is a fairly wet and can be a fairly mild climate, especially during the summertime. And with your Mediterranean climate, typically, again, a little bit drier, especially during the summer months. And you'll notice that your temperature range it's not huge. You can see LA, the average temperature as we get into even into the summer months isn't overly extreme. And again, with that Mediterranean climate, look at warm summers, kind of coolish winters, but certainly not overly cold. All right, here, now we're getting into our humid continental climates with more severe winters, and this is referring to a D climate. And first thing I want you to notice, this is Chicago and Ontario. Look at the huge difference in temperature. It's like a mountain as we go throughout the year. So the temperature range is huge, but you can see those winter temperatures definitely colder as compared to our sea climates. But you can have some pretty warm weather during the summer months. You can see in Ontario, we're way up there. We're on the southern edge of the Hudson Bay. You'll notice temperatures into the upper 60s during the summertime, but average temperature of about -4 degrees Fahrenheit for the month of January. And that also goes for December as well. And that can lead to severe, harsh winters. So this kind of climate is typically going to be land controlled. The annual temperatures are huge, and the maximum precipitation occurs typically during the summertime. And you'll notice the trend throughout the year, there's a little uptick in Chicago during the summertime. Same deal with Ontario as well. Now you got your subarctic climates, and this is getting you farther north. And this is when you have very long cold winters and short, warm, hot summers. And you typically average about 50 inches of precipitation. Normally, once you're getting into the higher latitudes, you're getting away from the influence of the jet stream. If there's too much cold air in place, you're not going to, and you don't have any sort of moisture source nearby, obviously you're not going to be condensing much moisture, and so that's going to leave the area fairly dry and, of course, very cold. And finally, as we kind of wrap things up, we're looking at the polar climates here. You can see this is Point Barrow, Alaska, the northernmost city in America. It's referred to as a different name now. I can't pronounce it. It starts with a U. You can look it up. But we'll say Barrow, Alaska at 71 degrees north. And again, you'll notice the significant range in temperatures. But look, we're still below 50 degrees even during the warmest time of the year. And that's what makes it a polar climate. Another thing, notice just the lack of precipitation. Again, we're away from a moisture source. Yes, we got the Arctic Ocean, but that's typically covered in ice. The air is so cold as it is. It's cold and dense. It's not rising, even though you are right next to a water source in the Arctic Ocean. But the Arctic Ocean is not going to generate a lot of buoyancy and lift to create that precipitation. The tundra, basically large areas of permafrost. I mean, that's where the ground is like concrete. Matter of fact, there's a school in Barrow, Alaska, where I remember seeing this story on ESPN about, I think, some woman in Florida. She basically bought the high school an artificial turf field because they were essentially playing on a natural surface, which up in those latitudes, that's permafrost, and that's like playing on concrete. So that's just how severe and unlivable those conditions are. But you still have folks that find a way to adapt and live in these very harsh regions. Now in the poles, small amounts of precipitation with a little bit more during the summertime. Short summers, 10 degrees Celsius or a little less than that. And you can also find these in higher elevations, obviously high latitudes. And so if we go from the tundra to the ice cap climates, and that's when no monthly mean temperature is above zero. You're talking about glaciers here, permanent snow and ice. And the highland climates, which that's actually its own little classification, really outside of the various letters we've spoken about. These are mountain climates and are usually a little bit cooler and wetter than those at lower elevations. A lot of times you'll notice these regions are kind of encased in fog, get a little bit of lift along the side of the mountain that will generate some of that precipitation. All right, so that is that. We'll talk a little bit more about our local climate. I'm going to go into a little bit of a discussion about that next go around. But I just want to kind of hit some of the main topics. Again, if we scroll back, I think the big chart that you really want to look at is this. This kind of puts everything into perspective here. Just want you to remember that in your A climates, it's not so much the amount of precipitation. As a matter of fact, it's just the average temperature range. And your coldest month isn't even cold. Now, for your B regions, that's generally referring to precipitation. It's always referring to precipitation, but evaporation exceeds precipitation. But even in a dry climate, you can still get a little bit of precipitation. But in the deserts, that's where you end up with really 2 inches or less of rainfall in any given year. Into your sea climates, that's where you have more that mild weather, at least milder winters overall. And you've got those various precipitation ranges throughout the year. Now into your D climates, that's where we have more severe winters. That's really where you're getting into the northern latitudes. You've got pretty significant temperature ranges. That goes for C as well, but huge temperature ranges with your D climates. And you can see there's a lot of crossover between C and D. And then into your E climate region, that's typically towards the poles. And it's cold all year round. Obviously, you have your tundra and then you have your ice caps. Your ice caps, warmest month is going to be 0 degrees or below because it's snow-covered ice cap. Obviously can't get any warmer than that, although as we talk about climate change next week, obviously we're going to talk about these various climate regions and how they've been changing, unfortunately, because of what humans have been doing. And we're also going to talk about the different techniques of kind of looking at climates over the course of history and how obviously where we're getting more measurements nowadays and how we can compare that to things like ice core samples that we've been able to look at and kind of determine what the climate was like many, many years back. We'll talk about those fluctuations in climate, the natural climate change that occurs, but how humans have also been influencing that. That's really going to take us towards the end of the year. But for the assignment coming up, again, if you haven't finished your assignment referring to severe weather, your severe weather event or your tropical weather event, please try to get that to me as soon as possible. I'll also send out an email because I think some of you guys are missing some previous assignments. I'll kind of hit on which ones you've missed. And I'm also still in the process of grading the test. It's been a tough time for me as well, trying to adjust to everything. The biggest problem I'm going to have with the test is that it's going to be hard to really give you feedback on it. So I'm still working on that. And I'm still working on the case study example, but check your email about the final because we're, about a month out now from that. And I want to make sure that you can kind of get your juices flowing up there in terms of what you want to do as your final project. And the case study, again, I'll get to that next week, I promise. It's not going to be anything overly tough. It will just kind of be an extended assignment. So that week that it's assigned, probably give you like 2 weeks to complete it. Heck, I'll probably give you towards the rest of the year to finish that up. It's just going to be a little bit bigger than just an assignment where break down a storm system. And I want you guys to be able to use what you've learned over the course of the last several months to kind of analyze a situation. So, sound good? Again, we'll talk a little bit more. We'll talk more about climates. We'll talk more about our climate. We'll kind of rehash some of these various regions since did go through a lot in a fairly short period of time. But until next time, hope you guys again are staying safe. If you have any questions, please direct them my way.